Hello, in this video I'm going to take you through trace tables from flowcharts. Trace tables are used to dry run a program. Remember, these are flowcharts. You cannot run a flowchart in a computer, so you have to go through the program step by step using your manual means. Now, their main purpose is to indicate the purpose of the program to the user, or they can be used to find any errors within a program. So that is the main purpose of our trace tables. When you are building trace tables, you want to have the instruction line number, so instruction 1, instruction 2, instruction 3, something like this. Then you want variables and also outputs. When variables change, you take note of the change. When there is an output, you take note of the output at each and every line of the program. That's how we deal with trace tables. Let's look at an example and see how this works. First, we are going to draw our table. The first variable is num. The second variable is double. The third variable is triple. And the last column, it's not a variable, it's an output or a display. So step 1, we ask the user to give us a number. Let's just suppose the user gave us a number of 10. Line number 2, we change the value of double to become num times 2. So line number 2 here, double is 10 times 2, that's 20. Line number 3, we have triple. Triple is num times 3. Num is 10, multiply that by 3, you get 30. Line number 4, we display double followed by triple. So the output is 20 followed by 30. In this program, we just showed what is happening to each and every variable during the execution of the program. That's the trace table. All right. We have another program here. We are looking at a variable called age. There is no other variable. We have display or output. So, line number 1, the user gives us their age. So, let's suppose I am the user and I give you my age. Then, there's something really wrong with this flowchart. I didn't actually get to see it in time, but the arrows are all pointing in the wrong direction. So please reverse these arrows so that they point in the opposite direction. They point down, down, down like that. All right, that's a mistake which I made during drawing the trace table. All right. So line number 1, input age. Suppose I put 30. Line number 2, I ask is age greater than or equal to 18? Well, in my case, the response is yes. So, line number 2, the response is yes. That response is not going to change the value of age. So look, there is nothing here. There is nothing happening there. Line number 3, number 3, we display, because I went to the yes side, we display adult. Then the program ends. That's it. I want you to test out the trace table using an age equal to, say, 14. Let's see how things go. This is another trace table. I will do this as the last one. We have variable called count, and we also have display. So this is line 1, line 2, line 3, line 4. Right. We start our program. Line number 1, we set count to 1. So there we go. Line number 1, count becomes 1. Again, the arrows here are pointing in the wrong direction. Please fix that mistake. The arrows should be pointing down. All right. We go to line number 2. We have the question, is count less than or equal to 3? The answer is yes. The answer is yes. So I'm going to display 1. Line number 3, that's when I display 1. I'm a little distracted by my arrows there, but let's carry on. Line number 4, we increment count. Count is 1 plus 1, old count plus 1. So count is now 2. Then the program comes back. Is count greater than or equal to 3? The answer is yes. Count is 2. We display count. That's line number 3 again. We display 2. Line number 4. Count is incremented by 1. Count becomes 3. We go back. Is count greater than or equal to 3? The answer is count less than or equal to 3? The answer is yes. We display count. So line number 3, we display count is 3. Line number 4, count becomes 4. And we go back. Is count less than or equal to 3? This time it's no, because count is now 4. We go to the end of the program. So the purpose of this program is to display 1, 2, 3. That's it. All right, so that's how flowcharts works. When you look at this program that we just did, there was a for loop within this program. Because we kept repeating, we knew we were supposed to repeat 3 times. So by completing the trace table, I'm getting a better understanding of the algorithm at hand.